So today we did the final lesson of building quadratic functions to describe situations. We still have lots more lessons in this unit, but week after next week is our testing week because that's right before spring break. So, just don't fall behind. Today we specifically looked at revenue situations. What is revenue? It has to do with money. It has to do with how much money is being made, right? So, yeah, we looked at if they charge this much and they're selling this much, we had to multiply that to get the revenue. So you might have to do that again in your homework. Usually the homework is different problems from our notes, just some different numbers. So the reason why that's in this unit is because it can be represented by a U-shaped graph. Namely one that looks like this. Because there is a part where they can get maximum revenue, and there is usually two values that they would make no money off of. So we saw that if they charge $0, obviously they're not going to make any money if they're giving it away for free. And then if they charge too much money, then no one's going to buy it. That's why there's 2 zeros for that. So you got to know where to look on your graph to find the answer. I think you guys are lucky in that they really drag out quadratics. Like unit 6 is just about conceptual stuff about quadratics. Unit 7 is when you actually start solving them yourself versus just graphing them. So right now you're kind of lucky. You can just graph it and know where to look. So what information does the vertex tell me about my graph? Make sure to pay attention. What information does the vertex tell me about my graph? Highest point, so my maximum. It could also tell me my lowest point too, but most of our real world situations look like this. They could tell you your highest point or your lowest point, your turning point. It's always two values. You have to decipher which one is going to answer the question. So in our revenue problems, it was price in dollars, and the y-axis was revenue. So if it said, what's the maximum revenue? Would you tell me the X or the Y of my vertex? The Y. If I asked you at what price do I get the maximum revenue, what value would you tell me? The X. So just read the graph. You get so much from just reading the graphs. And lastly, what's another word for zeros? X-intercepts. So be able to identify your x-intercepts and what they tell you about the situation. By definition, your x-intercept is when y equals 0. So in this revenue situation, that's what's on my y-axis. Our zeros tell me when they make no money. That's what it tells me. And this is where I look, because it's my x-axis, right? So just be able to connect all of those dots. And also one other thing we saw, what's x times x? Okay, don't forget that. It's one of the exponent rules. Remember I had you do a maze and a iHeart exponents coloring sheet? Those are important. Granted, we don't use all of those rules all the time, but you need to know, because it's quadratics, that x times x is x squared. Speaking of those worksheets, if you're not loving your math lab grade, it's probably because you didn't turn in one or both of them. So you probably will have extra time today because you did have some time in algebra to do this practice, 6.07. After that, let me know. What do you want to help with figuring out? Do you need help with the worksheets? Do you need help with algebra? What is it? Because you should be working to improve either of those grades when you have this extra time. And some of you, there's no replacement for doing better on the tests. If you need to do test corrections, you can do them in here, but you just have to ask. Otherwise, it's focusing on what we're doing right now. Like, are you doing it at 6? Because that's going to be our next test, but it's not even for like 2 more weeks. All right, so questions on what you're supposed to do today. All right, well then get to it. Others. So we're on the lesson 7, number 1. Based on past musical productions, a theater predicts selling this expression tickets when each ticket is sold at P dollars. Similar to what we did in the notes, but we're going to complete the table to find out how many tickets the theater expects to sell and what revenues it expects to receive at the given ticket prices. So your tickets sold, they are telling you, is given by this expression. And they're saying that the ticket price is going to be P. So this is what you're plugging into each of these, and that's what you're putting here. Okay, so I'm going to do that in a calculator off to the side. So 400 minus 8 times P, the first P value is 5. That 360 is going to go here. My revenue, so that how much money is being made, I need to multiply these together. Because if this is the price for each ticket and this is how many tickets I'm selling, that's how I'm going to get my revenue. So 360 times 5 is 1,800, and that goes here. Don't put any extra dollar signs or commas, like don't even put a comma unless it tells you to. That is how you're filling in all of this. So we could do a few. I don't want to do it all for you because I want you to now, since you should know how to do it, fill it in. But like this next row, once I plug in the 10 for the P, I get 320. For my revenue, I need to multiply those together. 10 times 320 is 3,200. Now, what's probably hard is, oh wait, it doesn't even have that row. So actually, these should all be easy from there on. Aiden? Okay. Any questions on this question? Can we go from there now that I helped you with 2 rows of it? If I need to go back to it, I can. But, Aiden, what question do you have next? Question 6 on the same practice. Okay, so a small marshmallow is launched straight up in the air with the slingshot. This equation tells us the height of the marshmallow in meters as a function of time in seconds since it was launched. About when does the marshmallow reach its maximum height? So there's no way for me to tell that just from the equation. I have to put it into my calculator. If I type it exactly how it was given to me, it should graph because it's in function notation. Otherwise, if you like left this part off, you'd have to make those t's x's in order for it to read it. Okay, but you do that and then you see the shape of the graph. What part of the graph do I look at for my maximum height? The vertex, which is the turning point. What value is the answer? Is it going to be 2 or 25? 25, right? Because your x-axis is the time, the y-axis is the height. So make sure you're putting the correct number. In this case, when it's just asking for the maximum, you're not going to put the whole vertex. You're just going to put the maximum, which is the y. Make sense so far? Yeah? Okay. So that's my maximum height. Oh, wait, actually it says when. So that changes it actually. It didn't say what is my maximum height. It says when does the marshmallow reach its maximum height? So what's the answer actually? Okay, good. Got to just read it carefully. Now about how long does it take before the marshmallow hits the ground? Where would the ground be in my diagram? The zeros. Notice I have two. Only one of them makes sense. Which one? The 4.2-ish one. Let me see if it tells me to round to something. It doesn't tell me what to round to. So I'm just going to put 4 for right now. But we'll see what it accepts. It didn't tell me to round to anything particular. Now, what domain makes sense for function h in this situation? And it has the interval with the inequalities. So I'd put my smaller x here and my bigger x there, because that would be saying that x is between those numbers. So what x value should I start at? 0. What x value should I end at? 4 or 4.2? Let me see what it accepts as answers. Okay, it doesn't like one of my answers. So let me see. Okay, so where I think it's heading, and let me see, there's only one way it's accepting it. The way that it's going is like you want your domain to include all the numbers in your situation, and I'm dealing with 4.2. So they rounded up to 5. Personally, I would say the domain has to be, let me add an answer. Okay, so it reaches its maximum height at 2, about 4. I'm gonna put the domain as like 4.2 as an additional answer, because it should really stop at wherever it hits the ground. On the real test, your unit test, it should be more clear, but I'll put that as an additional answer. Maybe I'll put some directions so that way it tells you more likely how to put the answer in. Okay. So I added an additional answer. You might not see it right away, but as long as you know for the test that your domain is all the x's and should include like reasonably where it starts and ends, then that will be fine enough. Okay, other questions? Aiden? Number 4 on this one? Okay. So function f represents the revenue in dollars. Guys, simmer down. That the school can expect to receive if it sells this much coffee mugs for X dollars. Here's a graph. Select all the statements that describe the situation. So at $2 per coffee mug, the revenue will be $196. So I'm gonna have to kind of zoom in on this. Does that Y value where the X is 2, does that look like 196? So don't pick that one. Okay, table 6. Shh. The school expects to sell 160 mugs if the price is $5 each. So let's see, the price is $5, so look at the X. C, does it touch? I really can't get that information from the graph. Let me see. Does it say how much I'm selling the mugs for? Okay, hold on. So it does say 220 minus 12x coffee mugs. So let me play around with that. 220 minus 12 times X being the price. I do think that's one of the answers. We'll see in a second. Because this expression tells me how many mugs I'm selling, at least predicted to. And when I plugged in $5 for the X, it gives me 160. So I am going to pick that one as one of them. The school will lose money if it sells the mugs for more than $10 each. So that's easy to see on my graph. Here's where it's $10. Are they not making money after the $10 point? They are. There's a line here, so this is still in the positives. I mean, it's not enough as much as before 10, but they're still making money, so they're not losing money. The school will earn about 1,000 if it sells the mugs for $10 each. So at the $10 each, does that look like about 1,000? So we are going to pick that one. The revenue will be more than 700 if the price is between 5 and 14. So here's about 5, here's about 14. So here, let me look this way. Here's where 700 is. I would go with that one. Here's where 700 is. It starts at the 4 and it ends at the 14. So I would say it includes 5 and 14. The expected revenue will increase if the price per mug is greater than $10. And actually, that's past the $10 is where it starts to decrease. So I would not pick that one. I would just pick these three. Let me make sure it's right. And it is. So don't just blindly pick. Make sure you're picking these three and none and no extra. All right. Any other questions? Am I out of time, Gunner? Agree on this one? Okay. So a company selling running shoes, if the price of a pair of shoes in dollars P is a company estimates that will sell this much pairs of shoes, write an expression that represents the revenue R in dollars from selling running shoes if a pair of shoes is priced at P dollars. So this is kind of like what we did in the notes. Revenue is what we get when we multiply how much something costs by how much people are buying. The thing with this is it doesn't give you numbers to plug in, so it's just going to be an expression. So we're going to multiply. The way it's set up, it looks like the expression is going in here. So I'm going to multiply the price times this, because that's how much they estimate they'll sell. So it would go in this order, like that. So this is, if you look in the notes, this is similar, and I'll come back real quick. It's similar to this setup. Well, actually this one, the one that's boxed over here, where it's the price times how many are being purchased. They're just giving you the expressions. All right, Dan, what was your question? Question 5? Okay. So a rock is dropped from a bridge over a river, which graph could represent the distance fallen in feet as a function of time in seconds. So distance fallen is like that one lesson where it was like 16t squared, not the negative one, because that would give us the height. So I'm guessing the answer will be something that is positive, but it shouldn't be linear unless there's no gravity, and it didn't say there was no gravity. So with that being said, I'd go with that one. Let me see if the answer is, it's that one. Because this isn't telling us the height of the object, it's telling us how far it's traveled. That's that one lesson where, I don't know, it's like the same amount of travel no matter what the item is. Does that make sense? I don't know how to describe it. It's 16t squared, not negative 16. Yeah. All right. Well, if you have other questions, any